Okay, so I wanted to look at problem 6.3 with you too from page 117 in your book. So basically 6.3, and it's under the problems, not the examples. 6.3, the owner of a sand and gravel quarry is considering the purchase of trucks to deliver aggregate to customers. Two sizes are being considered, namely a 10 and 15 cubic yard diesel engine dump trucks. Haul distances will vary from 6 to 20 miles with an average of 12 miles. So what we're doing is we're going to compare two trucks, and I've laid it out here. First thing, one of the things that they said is that we should consider this a 45-minute hour. It is estimated that the 10 cubic yard trucks can travel at an average speed of 40 miles per hour, so that's one of our variables that we want to put in here. And that's full and 50 miles per hour when it's empty, while the 15 cubic yard truck can travel at an average speeds of 30 miles per hour loaded and 45 miles per hour empty. So just getting all of these elements in here. And actually the way I started is I just did one side of it. The trucks will be loaded with stockpiles of aggregate using a loader that has a production rate of 115 cubic yards per hour. And the average truck time at the dump will be 4 minutes for the 10 cubic yard truck and 5 minutes for the 15 cubic yard truck. Assume that the trucks and the loader will operate 45-minute hours. So we've done that. The cost of a 10 cubic yard truck is $27.50 per hour, and the 15 cubic yard truck is $34.75 per hour. And you can imagine the many ways you could come up with that hourly cost. You could probably do like we did a capital account or a sinking fund type of equation. You could look at rental rates, lease rates, but in any event, they're expressed as $27.50 and $34.75 per hour. And I should probably just add that in there, per hour. And then the operator, no matter which truck they're driving, the operator is the same cost of $18.50 per hour and $18.50 per hour. If we were going to get really technical too, we'd probably put some prices on the loader. So what we're doing is we're figuring out what is the cost per cubic yard to operate these. I'm just going to spread that out a little bit. So the way I went about it, first thing, started out, put down all the information. Everything they gave me in the problem, just kind of checked it off. So I had a 45-minute hour, 10 cubic yards on this truck, 40 miles per hour loaded, 50 miles per hour empty, the unload time of 4 minutes for the 10 cubic yard, 5 minutes for the 15 cubic yard, average distance of 12 miles, same loader, 115 cubic yards per hour. So first thing we're going to do is we're going to figure out how long it takes to load it, how long it takes to haul when it's loaded, how long it takes to unload, and how long it'll take to return. So when we were figuring the loading time, 10 cubic yards, the loader's 115 cubic yards per hour, so 10 cubic yards divided by 115, and that's cubic yards per hour. The cubic yards cancel out. It gives us 0.087 hours. To haul, we're driving 12 miles at 40 miles per hour, so that's taking us 3/10 of an hour. To unload, 4 minutes, right? Just strictly 4 minutes. And there's 60 minutes in an hour, right? So because we're doing these all in terms of an hour. And then the return time, we're going to go a little faster. We're going to drive 50 miles per hour on the way back. So figuring that it's 0.694 of an hour is our cycle time. And we can multiply that by 60 minutes and get the actual minutes. So it's what, probably between 37 and 40 minutes. Curiosity's killing me. So 41 minutes. So that is that's our time. That's our cycle time, 0.694 of an hour. So now we need to figure our production rate. And the way we're going to figure the production rate is we are going to take one cycle and divide it by 0.694, which is the hour time period that we're taking, and then we're going to multiply it times the cubic yards in the truck, and then we're going to multiply that times D4. I made as a 45 hour, so it's a figure in here. It's a variable. I mean, if we went to a 50-minute hour or 40-minute hour, then we could change it. But we're just dividing that by 60. So that's giving us a production rate of 10 cubic yards per hour, 10.8 cubic yards per hour. So in the same exercise over here, the variables just changed in terms of a larger 15 cubic yard truck, and then the a little more productive during the cycle time's a little bit longer, but we have 15 cubic yards. So we're doing 13 cubic yards per hour here. So, and we figured our hourly costs of each vehicle, and just basically went and divided the cubic yards per hour, the cost per hour by the cubic yards per hour, and we've got $1 cost per cubic yard. The hours cancel each other out. So that is what, very simple. I mean, it seems like a very difficult problem when you look at it, but if you just break down everything that they offer you, all the information, get those variables in there. You want to figure a production rate. We know the hourly cost, it was kind of given to us, and then we want to know our cycle time. So this is really here is our cycle, the cycle time for that. So 425 per cubic yard to move on the 10 cubic yard truck, and 390 on the 15 cubic yard truck. Clearly, I think we're going to choose the less expensive option and go with a 15 cubic yard truck. So, all right, that's that.